Hello friends, in this AV we are going to take up the numericals of the chapter Calorimetry. We will be talking about the numericals of exercise 11A. The first numerical says, by imparting heat to a body, its temperature rises by 15 degrees Celsius. What is the corresponding rise in temperature on Kelvin scale? Here they are asking about the rise in temperature in Kelvin scale. They are not asking us to convert this degree Celsius to Kelvin. So we do not have to add 273. What we will do is, we have just written that the size in Kelvin scale for 1 degree is same as the size in Celsius scale for every 1 degree. So the temperature difference is the same on both Celsius and Kelvin scale. So therefore the corresponding rise in the temperature on Kelvin scale will be 15 Kelvin. For deeper understanding of this, you may refer to equation 11.3 of your textbook. Numerical 2 says, calculate the heat capacity of copper vessel of mass 150 grams if the specific heat capacity of copper is 410 joule per kg per Kelvin. And the second part of the question says, how much heat energy will be required to increase the temperature of the vessel in part A from 25 degree to 35 degrees Celsius. So from 35 to 25, from 25 to 35, the increase in temperature is of 10 degree Celsius. So let's first calculate the heat capacity of the copper vessel. So here we have written the mass of copper vessel is 150 grams, and we know that it's not given in its SI unit, so we convert it to kg by dividing it by 1000. So specific heat capacity of copper is given as 410 joule per kg per Kelvin. So heat capacity is given as mass multiplied by specific heat. So we have the mass given to us, we have the specific heat given to us, we multiply it, and we find the answer as 61.5 joule per Kelvin. Now for the second part of the question, the change in temperature is 35 minus 25 degrees Celsius, which comes to be 10 degrees Celsius. So energy required to increase the temperature of the vessel, that is delta Q, is equal to mass into specific heat into change in temperature. So mass is given to us 0.15 kg multiplied by specific heat, which is 410, multiplied by change in temperature, that is 10 degree Celsius. So when we multiply, the answer comes out to be 615 joules. The third numerical says, a piece of iron of mass 2 kg has a heat capacity of 966 joule per Kelvin. We have to calculate the heat energy needed to warm it by 15 degrees Celsius and its specific heat capacity in the SI unit. So specific heat capacity SI unit is joule per kg per Kelvin. So here we have written mass is 2 kg, heat capacity is 966 joule per Kelvin. So heat energy is equal to heat capacity multiplied by change in temperature. So heat capacity is 966 multiplied by change in temperature, we have to raise it by 15 degrees Celsius. So 15 degree. When you multiply, you get the answer for the first part. The second part of the question says we have to calculate the specific heat capacity in its SI unit. So the specific heat capacity is given as heat capacity divided by mass. We have calculated, we have the heat capacity given to us 966 joule per Kelvin, and we have the mass given to us. So we calculated and it comes out to be 966 divided by 2, so 483 joules per kg per Kelvin. Question number 4 says, calculate the amount of heat energy required to raise the temperature of 100 grams of copper from 20 degrees Celsius to 70 degrees Celsius. So first of all, 100 grams needs to be changed to kg, and the change in temperature would be 70 minus 20, that is 50 degrees Celsius, and they have also given us the specific heat capacity of copper to be equal to 390 joules per kg per Kelvin. So here we have written the given things. Mass of the copper is 100 grams. Converted to kg, it comes out to be 0.1 kg. Change in temperature is 70 minus 20, that is 50 degrees Celsius. Specific heat capacity of copper, which is denoted as C, is 390 joules per kg per Kelvin. So the amount of heat required to raise the temperature of 0.1 kg of copper is, the formula is Q is equal to M, that is mass, multiplied by change in temperature multiplied by the specific heat. All the values are provided to us. We just put the values. Mass is 0.1 kg, change in temperature is 50 degrees Celsius, and specific heat capacity is 390 joule per kg per Kelvin, which is given in the question. When you multiply, you get the answer as 1950 joules. Numerical 5 says 1300 joules of heat energy is supplied to raise the temperature of 0.5 kg of lead from 20 degrees Celsius to 40 degrees Celsius. That means rise in temperature is 20 degrees Celsius. Calculate the specific heat capacity of lead. So first of all, we write the given things, that is heat energy supplied is 1300 joules, mass of lead is 0.5 kg, change in temperature is 40 minus 20 degrees Celsius or 20 Kelvin. Now specific heat capacity of lead, that is C, this comes from the formula delta Q is equal to MC delta T. So from there C is equal to delta Q upon M cross delta T. So delta Q, that is heat supplied, is 1300 joules, mass is 0.5 kg, and the change in temperature is 20 Kelvin. So when you simplify it, the answer comes out to be 130 joules per kg per Kelvin. Now the next numerical, that is question number 6, says find the time taken by a 500 watt heater to raise the temperature of 50 kg of material of specific heat capacity 960 joules per kg per Kelvin from 18 degrees Celsius to 38 degrees Celsius. Assume that all the heat energy supplied by heater is given to the material. So they are assuming that there is no loss of heat. Now let's write the given things. The change in temperature is 38 minus 18, that is 20 degrees Celsius. So we have written specific heat capacity of material, that is denoted as C, is 960 joules per kg per Kelvin. Change in temperature delta T is equal to, here we are taking it as capital T because we have to find out the time which we are going to denote as small t. So change in temperature delta T is 38 minus 18, that is 20 degrees Celsius or 20 Kelvin. Power of the heater is given to us as 500 watt. So we know that heat is equal to MC delta T. So we just write the values. We do not simplify it now. We will simplify it in the later part of the question. So time taken by the heater to raise the temperature of material, T, this small t is time taken, is equal to delta Q by the power. So delta Q is this 50 into 960 into 20 divided by power rating is 500. So it comes out to be 1920 seconds. Converted to minutes by dividing it by 60, it comes out to be 32 minutes. So that's all we have in this AV for you. For the remaining part of the numerical, you will have part 2 of this AV. Thank you so much. Happy learning.